Hey everyone, let's do a couple of telescoping examples. Remember that telescoping is a convergence or divergence test using partial fractions. But we haven't seen a diverging example yet. Maybe we'll see one right now. Or maybe the next one, so to speak. Remember that in this case, we can rewrite this using partial fractions. So we want to rewrite 1 over, well, this is n plus 3 times n plus 1. And we want to write it as the sum from 1 to infinity of a over n plus 3 plus b over n plus 1. Guess we didn't need the parentheses, right? Whoa. Maybe get rid of those guys. No need to be confusing, right? There we go. Anyway, off to the side, you can see that this is going to be a n plus 1 plus b n plus 3 equals 1. Letting n equal negative 1 gives us 2b equals 1, b equals 1 half. Letting n equal negative 3, well, that's going to give us negative 2a equals 1, which implies which implies a equals negative 1 half. Okay, so them's our answer. That's great. Okay, so now we can rewrite this as negative 1 half over n plus 3 plus 1 half over n plus 3. Now, let's see where this takes us, right? If we start telescoping, if we start writing out the first couple of terms, then we're going to get, we plug in n equals 1, and we're going to get negative 1 half over 1 plus 3 plus 1 half. Oh, whoops, sorry, this should be n plus 1, sorry. 1 half over 1 plus 1 plus negative 1 half over 2 plus 3 plus 1 half over 2 plus 1. Okay, nothing's really canceling yet. Plus negative 1 half over 3 plus 3 plus 1 half over 3 plus 1. And now, if you're careful, you might start to see that that's canceling. Maybe let's do one more to see the pattern. Negative 1 half over 4 plus 3 plus 1 half over 4 plus 1. You say, oh, wait a minute. It's canceling out this guy. So it seems like, again, just to do one more term, just to nail down this pattern over here, right? 5 plus 3, 5 plus 1. 5 plus 1 and 3 plus 3 are the same thing, right? So it always looks like these two terms are going to stick around, and these two terms are going to be there as well. Okay, plus blah, blah, blah. Okay, so the nth term, right, the nth term, i.e. the nth partial sum, is the following. It's going to be 1 half over 1 plus 1, or 2, plus 1 half over 2 plus 1, plus negative 1 half over n plus 3, plus negative 1 half over n plus 4. Or maybe I could say n plus 1 plus 3 if you'd prefer. How am I getting that? Well, let me get a highlighter out here. Highlighter out here. I hope we see where these guys are coming from, right? But what about this guy? Well, this guy comes from here, right? The only difference was the 4 became an n. All right, yeah, an n, and then the next term became an n plus 1, right? Yes, maybe technically speaking, this is the n plus first term, but same thing. Okay, so anyway, what we do is we find our series, right? Our series is the sum from 1 to infinity of negative 1/2 over n plus 3 plus 1/2 over n plus 1. And this equals, well, all of this stuff right here. But the limit as n approaches infinity. You know what? I'm not going to fit it on this line, so I'm going to have to do it down here. As n approaches infinity of 1/2 over 1 plus 1 plus 1/2 over 2 plus 1 plus negative 1/2 over n plus 3 plus negative 1/2 over n plus 1 plus 3. And I think we see what happens when we take the limit as n approaches infinity. We get 1/2 over 2 plus 1/2 over 3 plus 0 plus 0. Okay, so our series converges to 1/2 over 2 plus 1/2 over 3, which I think 1/4 plus 1/6, I guess, is what we're talking about here, which is 3/12 plus 2/12. I guess that's 5/12. Right? 1/4 is 3/12. 1/6 is 2/12. Yeah, so there we go. Now remember, this is one of the few cases where we show what our series converges to. This will not always be the case. Okay. Let's take a look at number 2. Here, now I said telescoping is a partial fractions technique. I guess that's not always true, right? Here we have an example where we don't have partial fractions. Now let's take a look at this in two different ways. On the one hand, we might take a look at this and say, okay, sum 1 to infinity of 2 to the n minus 2 to the n minus 1. Well, maybe that equals, if we start plugging stuff in to the n, right, start telescoping. We might say, well, hold on a second, stuff is canceling left and right here. Right, do one more term just to confirm, but it looks like the only term remaining is this guy and this guy. But the problem is, okay, let's consider that, right? This is going to be the limit as n approaches infinity. Well, the nth term looks like it's negative 2 to the 0 plus 2 to the n, right? Again, we're replacing, right? This should be clear. And this 4, right? On the fourth term, we had 2 to the 4th. On the nth term, we have 2 to the n. And this limit is infinity. So the series diverges. And again, that's a different answer from what we've gotten before. There's a way maybe we could have intuited this. If instead of telescoping like this, we just, subtract it in the moment, we would get 2 minus 1 plus 4 minus 2 plus 8 minus 4 plus 16 minus 8 plus blah, blah, blah. And we say, well, wait a minute. This is, let me switch this to red maybe. This is 1 plus 2 plus 4 plus 8. Well, that obviously diverges, right? Obviously. In fact, we could have rewritten this as 2 to the n minus 1. And by the test for divergence, we see that this whole thing, right, that's the sequence. So, of course, the series would diverge. So just two different telescoping arguments. Be a little careful with it.